A trail camera hidden deep in a Florida preserve captured something researchers weren't looking for, and once they saw it, they couldn't stop watching it on repeat. This isn't a story about a giant snake terrorizing a swamp. That story has already been told 100 times on the evening news. This is the story of what happened after the cameras stopped rolling on that narrative, when scientists quietly started noticing that the swamp itself was writing a different ending. For nearly 3 decades, one question has hung over South Florida's wetlands. What happens when you drop an apex predator into an ecosystem that has never had to defend itself against one? The Everglades gave us the answer, and it wasn't pretty. But newer answers are starting to complicate the old one, and they're coming from directions nobody expected. To understand why new footage from the Everglades matters, you have to understand what an intact Everglades used to sound like. Field biologists who worked the region in the 1980s and 1990s described driving the gravel levees at dusk and constantly slowing down for wildlife. Raccoons ambled across the road in packs. Possums froze in headlights every few hundred yards. Marsh rabbits darted through the sawgrass margins, so often that spotting them barely registered as noteworthy. That soundscape is gone. Researchers running standardized road surveys along the same routes decades later reported stretches of hours without seeing a single mammal larger than a rat. Formal population studies eventually put numbers to the silence. Raccoon sightings collapsed by more than 99%, opossum sightings fell by nearly the same amount, and bobcat encounters dropped by roughly 87% across the survey area. Marsh rabbits and foxes, once common enough to barely warrant a note in a field journal, essentially vanished from detection entirely. The cause traces back to a single introduced species, the Burmese python. Native to Southeast Asia, the snake arrived in Florida through the exotic pet trade of the 1970s through 1990s, when a hatchling python could be purchased for the price of a video game. Owners quickly discovered that a docile foot-long snake becomes an unmanageable 10-foot predator within a few years, and many simply released their pets into the nearest canal. A 1992 hurricane that destroyed a breeding facility near Miami is often cited as an accelerant, scattering an unknown number of animals directly into prime wetland habitat, but the pet trade had already been seeding the population for years before that storm ever formed. Without natural predators, disease pressures, or hunting pressure from a native ecosystem that had never evolved defenses against an ambush predator this size, the python population expanded largely unchecked. A single female can produce dozens of eggs in a clutch. Estimates of the current wild population range from the tens of thousands into the hundreds of thousands, spread across roughly 1.5 million acres of preserve land that make thorough removal effort close to impossible. Florida has not been passive about the problem. State agencies, contracted hunters, and volunteer programs have poured years and considerable funding into python removal. The most visible of these efforts is an annual public hunting competition that draws participants from across the country, offering cash prizes for the largest and most numerous catches. In its most recent iteration, organizers reported roughly 1,000 registered hunters removing several hundred snakes over a 10-day window, a genuinely impressive haul for a short event. But scale the number against the estimated population, and the arithmetic turns grim. Cumulative removals across every program combined, stretching back over 2 decades, add up to a small fraction of the snakes believed to remain in the wild. Wildlife biologists studying detection rates estimate that hunters, however skilled, encounter only a tiny percentage of the pythons actually present in a given search area because the snake's camouflage and ambush behavior make it almost invisible, even to trained eyes standing a few feet away. Technology hasn't closed the gap either. Thermal imaging drones struggle because a python's body temperature closely tracks the swamp's own ambient heat, erasing the contrast that makes thermal detection work. Robotic decoys built to lure snakes into the open have underperformed because pythons are ambush hunters that wait rather than chase, so a moving decoy simply doesn't trigger their strike instinct. A tracking method that implants transmitters in male snakes during breeding season and follows them to females has produced real results, but it only functions at a scale that covers a small fraction of the preserve. If the removal effort had simply stalled, that would be one story. What field researchers have documented instead is a population that appears to be adapting to the hunting pressure itself. Multi-year tracking studies from conservation researchers in Southwest Florida found that radio-tag snakes were shifting their range away from the roads and levees where human search effort concentrates, moving deeper into dense sawgrass and mangrove terrain that is nearly impassable on foot. Whether this reflects individual snakes learning to avoid disturbed areas, or simply reflects a selection effect in which the boldest, most visible snakes get removed while cautious ones survive to reproduce, the practical outcome is the same either way. The population as a whole is becoming harder to find. Genetic testing has added another wrinkle. Screening of several hundred captured pythons found that a meaningful minority carried DNA from a second species, the Indian rock python, indicating hybridization between the two. Because the two parent species favor different habitat, one preferring wetter terrain and the other favoring drier, higher ground, a hybrid population potentially gains access to a broader range of Florida landscape than either parent species could occupy alone. A brutal cold snap in January 2010 offered an unplanned experiment in natural selection. Temperatures dropped low enough to kill a large share of the python population outright, and for a moment it looked like nature had done what removal programs could not. But researchers tracking survivors noted that the snakes that lived through that winter were not a random subset. They disproportionately carried traits associated with cold tolerance, and they passed those traits to subsequent generations. Rather than weakening the population, the freeze appears to have filtered it, leaving behind a more cold-hardy python better equipped for the occasional Florida winter that once might have kept the species in check. This is where the new footage comes in, and where the story stops being a simple account of an invasion nobody can slow down. In December 2022, a research team following a radio-tagged 52-pound male python into a national preserve found something they didn't expect at the end of the signal. The snake was dead, its head bitten clean off. A trail camera positioned at the carcass recorded the animal responsible for the kill returning the following day to continue feeding. It was a bobcat, weighing roughly half what the python had weighed alive. The lead researcher on that project described the moment as genuinely stunning. A bobcat is, in most contexts, roughly the size of a large house cat with slightly longer legs. For that animal to successfully kill and consume a python nearly twice its own body mass upends a lot of assumptions about who holds the advantage in that encounter. Examining the kill pattern, researchers concluded the bobcat had likely targeted the python during a vulnerable window after a large meal, when the snake's body temperature and reflexes slow dramatically as it devotes its energy to digestion. A python that has just eaten is, for a period of days, essentially an easy target for anything willing to approach it correctly. That kill was not an isolated event. Earlier trail camera footage from the same general region had already captured a bobcat raiding an unguarded python nest, consuming eggs and returning for more the following day. A separate research team monitoring a tagged female python recorded a bobcat confronting and killing a 14-foot mother snake at her nest, destroying dozens of eggs that would never hatch. Black bears have been documented preying on pythons during cold snaps when the snake's muscles seize up and it can barely coil to defend itself. A Florida panther was filmed taking down a mid-sized python in open sawgrass. None of these individual events reverses 2 decades of population decline on their own. A single bobcat kill does not undo the damage inflicted by hundreds of thousands of snakes over 20 years. But the direction of the trend matters as much as the scale of it. For most of this invasion's history, the predation has run entirely one way, python eating native wildlife with no consequence in return. The fact that multiple native predator species, independently and without any human intervention, appear to be identifying and exploiting the python's post-meal vulnerability suggests the ecosystem may be starting to develop its own countermeasure, however slowly. While the python story dominated headlines, a much quieter recovery effort was unfolding several hundred miles north. The eastern indigo snake, North America's longest native snake species, was once common across the longleaf pine forests of the southeastern United States. Unlike most snakes, it doesn't rely on constriction, instead pinning prey and using powerful jaws, and it is immune to the venom of the rattlesnakes and cottonmouths it sometimes preys on. Mid-20th century land development stripped away the longleaf pine ecosystem the indigo depended on, and with it went the gopher-tortoise burrows the snake relies on for shelter. By the late 1970s, eastern indigo snakes had disappeared entirely from North Florida, not merely declined but functionally gone from the landscape. Reversing that took 4 decades of sustained effort. Habitat restoration projects replanting longleaf pine across thousands of acres, captive breeding programs raising hatchlings for roughly 2 years before release, and a phased reintroduction program that began releasing snakes back into restored habitat starting in 2017. By 2025, well over 200 captive-bred indigo snakes had been released into the wild population. The real breakthrough came in the fall of 2023, when a trail camera captured 2 small indigo hatchlings moving through the underbrush, animals that had not been released by any program but had been born in the wild. It marked the first confirmed wild birth of eastern indigo snakes in North Florida in roughly half a century, proof that the reintroduced population had crossed the threshold from a managed project into a self-sustaining population capable of surviving without ongoing human support. Even as those 2 recovery stories developed, a third and far less visible force was spreading through the same wetlands, one that had received almost none of the funding or media attention directed at the python problem. A parasitic organism known as the snake lungworm, despite its name not a true worm, had been quietly establishing itself in Florida's native snake populations for over a decade before researchers began systematically tracking it. In Burmese pythons, the parasite is essentially harmless, a minor passenger that the snake's large lung capacity easily tolerates. In smaller native species, the effect is very different. A heavy parasite load can fill a significant portion of a small snake's lung cavity, causing progressive suffocation over the course of days. Infected snakes grow weak, stop feeding, and are frequently found lying exposed in places they would never normally rest, a behavior change that itself increases their vulnerability to further predation or death. What makes the lungworm especially difficult to contain is that its transmission cycle no longer requires the python at all. Infected snakes shed parasite eggs in their droppings, which are consumed by cockroaches, which are in turn eaten by frogs, which are eaten by other snakes, continuing the infection chain indefinitely through the food web with no python needed at any step after the initial introduction. Since the parasite was first documented in a native Florida snake in 2012, it has been confirmed. Across dozens of counties and in the majority of Florida's native snake species, including species with no direct contact with pythons whatsoever. Formal surveillance of the parasite didn't exist in any organized form until a graduate researcher built a monitoring network essentially from scratch starting in 2022, a full decade after the parasite's initial detection. Overlay these 3 developments onto a single map of Florida, and an uncomfortable pattern emerges. The reintroduced eastern indigo population in North Florida is expanding and pushing southward into surrounding habitat as its numbers grow. The python population, meanwhile, has been detected moving steadily northward, following warmer temperatures and the connected waterway systems that link South Florida to the rest of the peninsula, with confirmed genetic evidence of pythons north of Lake Okeechobee. The lungworm parasite has moved fastest of all, already documented in counties in the far northeast of the state, hundreds of miles beyond the current range of any python, carried entirely by native snakes and amphibians rather than by the invasive species that introduced it. Nobody has yet mapped precisely where these 3 trajectories intersect, and nobody has directly tested whether the eastern indigo, the very species 40 years of conservation work was built to restore, can survive exposure to the lungworm parasite. What is already known is troubling enough on its own. Eastern indigo snakes appear on the list of species confirmed capable of carrying the infection. The animal that an entire generation of biologists worked to bring back from local extinction is already known to be vulnerable to a disease introduced indirectly by the same invasive species the recovery program was never designed to fight. The story the headlines have told for years is a simple one. An invasive predator devastated an ecosystem, and human effort has struggled to contain it. That story is true, but the new footage coming out of Florida's preserves complicates it in ways nobody anticipated. Bobcats are killing pythons on their own initiative. An ancient native predator is breeding in the wild for the first time in 50 years. And a parasite smaller than a fingernail, one that received almost no funding or public attention, may end up shaping the outcome of this entire ecological story more than the snake that made every headline. The Everglades is not simply losing or simply recovering. It is doing both at once, in directions that intersect in ways researchers are only beginning to trace. Whether the next chapter belongs to the bobcats, the returning indigo snakes, or the parasite riding quietly through the food web will depend on collisions that haven't happened yet, in a swamp that has spent 30 years proving it can surprise the people who study it most closely.